All right, so here we go. This is number 17 for optimization. So in the Rogalski textbook, that is on page 263. So here we go with optimization. It says, find the area of the largest isosceles triangle that can be inscribed in a circle with radius 5. Okay, so here we go. We have our circle. Let's throw in a radius of 5. Instead of me drawing this radius just anywhere, I'm going to draw it specifically in two places. I'm going to draw it right here, and I'm going to call that 5 because that is set. And I'm also going to draw it right there, and I'm going to call that 5, right? So we're trying to find the area of a triangle, right, that is the greatest. The area of this isosceles triangle that is the greatest. And so I need to introduce some variables because I don't have any variables here. You might be thinking, well, r is a variable, but r is not really varying. R is 5, and that's set. So what I'm looking at is if I were to drop this down right there, let's call this y right there, and I'm going to call this distance over here, I'm going to call this x. This distance right there, I'm going to call x. So now, looking at this triangle, I'm going to start by saying that the area of this triangle is equal to 1/2 times the base. Well, the base of this triangle is going to be, if this is x, and that's going to be x as well, so the base is going to be 2x, times the height. Well, the height in this case is y plus 5. So really I have that the area is equal to x times quantity y plus 5, because that 1/2 and the 2 cancel out, okay? So with this, I do not have the area function, which I'm trying to optimize in terms of only one variable, so I need a way to relate x's and y's somehow. Well, the good news is right here I have a right triangle, right, where x and y are the legs and 5 is the hypotenuse. So I'm going to say that x squared plus y squared equals 25, or 5 squared, right? And now when I look back at this, I ask myself, what is easier to solve for? There's not really one that is, obviously the one you want to solve for. So you can solve for x's in terms of y's or y's in terms of x's. It doesn't really matter. Let me go ahead and solve for y in terms of x's. So I have that y squared equals 25 minus x squared, or y equals plus or minus the square root of 25 minus x squared. I didn't put the plus or minus in there because, again, y represents a distance for me here, and so it doesn't make sense for y to be that negative distance. You could say, well, it kind of does if this base of the triangle were above that center of the circle, that point that represents the center of the circle, but that doesn't make sense for optimizing this, for getting the maximum. And so I'm not going to consider the negative there. I'm only going to consider the positive. So what that means is, with this, my area function now only in terms of x's is going to be x times quantity y plus 5, but y is just the square root of 25 minus x squared, right? And so that is my function that is what I'm trying to optimize, in this case maximize, which is area, in terms of only one variable, okay? So that's good news for me. So I'm going to bring that over here. I'm going to get rid of this. And I'm going to say that let's distribute through by the x, just to make it a little bit easier for me to differentiate. I guess it doesn't really matter, but I'm just going to do that. So a of x is equal to x root 25 minus x squared plus 5x, once I distribute by that x. So this is what I have, and now I'm going to begin the calculus steps, which are, let's differentiate. So a prime of x is equal to the derivative here. You have to use a product rule and the chain rule. So let's go ahead and do that. So it's going to be the first times the derivative of the second. Well, the derivative of this expression is going to be 1/2 times 25 minus x squared to the negative 1/2 times negative 2x. Right, so that's the first times the derivative of the second plus the second times the derivative of the first right, times 1. And then just plus this guy's derivative, which is just going to be 5. So simplifying this, I get that a prime of x is going to be equal to, so that 2 and that 1/2 are going to cancel out. So I'm going to have negative x squared divided by root 25 minus x squared plus root 25 minus x squared plus 5. Okay? So this is a prime of x. What I would do here is I would get a common denominator for everything just to make it a little bit easier on myself. So the common denominator is going to be that root 25 minus x squared. So if I do that, then you're going to get that a prime of x is equal to, everything's going to be over root 25 minus x squared. That just remains. When you multiply that by that, you're just going to get what's inside, which is just 25 minus x squared. And then here you just have plus 5 root 25 minus x squared. Okay? Which again could just simplify down just a little bit more into negative 2x squared plus, let's make it 5 root 25 minus x squared plus 25 all over root 25 minus x squared. Okay, so I'm going to be happy with that. That is my a prime of x. And now I'm going to go over here. I'm going to erase this stuff. And I'm going to set a prime of x equal to 0. And then see where a prime of x does not exist. Well, a prime of x does not exist when the denominator is equal to 0, so when x is equal to plus or minus 5. But again, it doesn't make sense for x to be greater than 5 because that's the radius of this circle. So, x is really constrained between 0 and 5. X being 0, I wouldn't even have a triangle. X being greater than 5, the triangle would not be inscribed in the circle. So x is definitely has to be between 0 and 5. And so seeing where the derivative doesn't exist is where either x is equal to plus or minus 5. Well, those don't make sense. Or x is going to be greater than 5 or less than negative 5, and to create a negative inside an even root here or there. And again, that doesn't make sense either. So I'm just going to say, let's say, I'll put down x equals 5, but then I'll kind of know that that is the absolute maximum that x could ever be anyway. Okay? And then over here, setting a prime of x equal to 0, I'm going to set negative 2x squared plus 5 root 25 minus x squared plus 25 equals 0. This requires a little bit of work. So if I were to move this guy over, I'm going to get negative 2x squared plus 25 equals negative 5 root 25 minus x squared. Let me divide both sides by negative 5. So that's going to give me 2/5 x squared minus 5 equals root 25 minus x squared. I would square both sides to get, and now I'm going to move this just so I can have more screen, right? So I'm going to bring this guy up here, and I'm going to say 2/5 x squared minus 5 quantity squared equals 25 minus x squared. So this is going to give me 4 over 25 x to the 4th minus 2 times that times that. So that times that gives me negative 2 times 2 is negative 4 x squared, and then plus 25 is equal to 25 minus x squared, right? And so for this, I'm going to subtract 25 from both sides, add x squared to both sides, and that leaves me with 4 over 25x to the 4th minus 3x squared, those cancel out, is equal to 0. So x squared times quantity, 4 over 25 x squared minus 3 equals 0. Well, here it's where x equals 0 or 4 over 25x squared equals 3. So that's going to be x squared equals, what is that, 75 over 4. Let me take the square root of both sides. You're going to get that, I'll put over here, x equals plus or minus, but again, x being negative doesn't make sense. And that's going to be something over 2. Oops. And up here, root 75. 75 is 3 times 25, so it's going to be 5 root 3. Okay. Now that I have that, that just gives me the values that represent the critical numbers that I'm going to put on my sign chart. Okay? So I'm going to go ahead and bring this board over here. Let me go ahead and erase this. And let's go ahead and put those values on the sign chart. So I have on my sign chart, I'm going to have, this is going to be a prime of x, and this is a of x. And 0 doesn't make sense for the x values, and it doesn't make sense for x to be greater than 5 over there. And so the value that I really just got was 5 root 3 over 2. Okay? So 5 root 3 over 2 is greater than 1. So I'm going to plug in 1 in for the derivative. The derivative is down here. When I plug 1 in for x, so a prime of 1, I'm going to get that that's negative 2 plus 5 times root 25 minus 1 squared, so that's going to be 5 root 24, and then plus 25 all over root 24. I don't care about the value of that, but all I am interested in is whether it's positive or negative. It's definitely going to be positive. So if a prime is positive, that means that the area function would be increasing. And then if I plug in something greater than 5 root 3 over 2 and 5, so something in between those, something like, let's see, 5 root 3 over 2, really quickly, just to make sure that 4 is going to be greater than that. 5 root 3 over 2. So 5 root 3 over 2 is about 4.33. So I need to plug in like 4.5. I'm going to plug in 4.5 in for that. So go ahead and let's do that. So a prime of 4.5. And again, I'm only looking whether it's positive or negative. In the denominator, you can see that that's going to be positive, right? So it's going to be something over a positive value. 4.5 quantity squared. 4.5 squared is 20.25 times negative 2 is going to give me 40.5, but negative, so negative 40.5 plus 5 times, and then the square root of 25 minus 4.5 squared. Let me go ahead and do that. 25 minus 4.5 squared, and I get that that's 2.179 something, and then plus 25. So this is slightly greater than 10, plus 25 is about 35 point something, but then minus 40.5, so this is going to be negative. Okay, so if a prime is negative on this interval, that means that the area function is decreasing there. And that indicates that I have a local max there at 5 root 3 over 2. So now answering the question asks, or it tells us to find the area. So it doesn't say what x value, right? It says find the area. Well, this function that I have here is the area function in terms of only x. So what I'm going to do is in my calculator, I'm going to plug in 5 root 3 over 2 in for x. So the maximum area is just a of 5 root 3 over 2, which in this case is equal to, let me go and plug that, or I'll do it by hand at first. 5 root 3 over 2 times the square root of 25 minus, so 5 root 3 over 2 squared is going to give me that 75/4 value, and then plus 5 times 5 root 3 over 2, okay? And now when I do that, I would say this is going to give me 5 root 3 over 2 times, inside there I get root 25 over 4, which is the same as 5 over 2, and then plus 25 root 3 over 2. So I get, let me erase some of this now. So I get that this is equal to 25 root 3 over 4 plus 25 root 3 over 2 times 2 times 2. And I'm going to get that that's 50 over 4 plus 25 over 4, which is 75 root 3 over 4. And that is the maximum area, or the area of the largest isosceles triangle that can be inscribed in a circle with radius 5. All right, there you have it. That's number 17 on page 263 for optimization. I hope that helps.